Okay, we want to create a tool holder for live milling for an Okuma LB3000 for y-axis offset, and this one has a couple of ERAX external clamping nuts as the output. This tool holder is made by Velocity, so it's basically an Okuma product. So the first thing that we want to do here is make sure that the orientation of the solid is correct. Currently, the way that it opened from the Velocity database, it is oriented in the wrong direction. So we want to change that. This is the face of the tool holder that is going to be up against the turret face. So we want the blue z-axis to be pointed up into the turret. So we can see here that this is not oriented correctly. But if I, inside of Esprit, if I just click on this face itself and I want to place that normal to z at z0, we have a function called align z to do that. So once I select that, you can see that the solid will be automatically snapped to the XY, or this face will be snapped to the XY plane at Z0, as you can see there. And now it looks like it's down the center, but just being an engineer, I want to make sure that everything is 100%. So very quickly I can center this z-axis inside of this cylinder by just picking one of the faces on the outside here and again hitting the align Z. Now, yeah, we didn't really see anything move there, but if it was off by 5 thou or 20 thou or something, it's pretty hard to tell, and it's just quick to just do that as a precautionary measure. So now we have everything inside of Esprit oriented correctly. Forgot about this. The red arrow is the arrow, the X or the U vector is going to be pointed toward our main spindle. So if I'm standing in front of the machine and this was in the turret, I actually want this to be flipped 180 degrees. So what I could do is hit Control A on my keyboard, or I'll click elsewhere and just right click and say select all. So you can group everything, or you can window in on everything like this by clicking and dragging. I'm going to right click and say copy, and I'm going to move, and I'm going to select rotate, and I'm going to pick 180. And I could either leave this checked or uncheck it and then pick the z-axis. I'll just leave it checked because it's easier. And now we can see that the offset tool locations are facing toward the main spindle, which is what I want. So when I open this inside of Esprit and I load it onto the turret, it will appear in this default orientation on that turret station. So as you're using Esprit or any CAD or computer software program, it could get bogged down with data, and if we don't need certain things, we'll get rid of it. So here we have some stuff on the top. Let's check and see if I can see this stuff anywhere when I highlight it. I don't. So these solids here at the top are not visible. They're going to be up into the turret once it's loaded in the simulation. So why should I bother including that? I'm going to just go ahead and hit my delete key and get rid of that. So there might be some things internally here. I don't know, is this a screw? No, there's nothing there. Okay. So what I'm going to do now is kind of maybe change some of the coloring. I see a couple of coolant lines down here. I'm going to window in on that, come to properties, and change the properties to something that kind of looks like brass. So the properties window is accessible from the home tab here. We've got all these tabs. The home tab, and then the show hide, the properties is at the top. Just make sure that is checked. and this box will be somewhere on the screen. So once I've done that, let's see what some of these other things look like. Do I want to change some of this? I'll just leave it all as gray. Maybe I'll change these externally threaded clamping nuts to be a little bit deeper color of gray. In fact, let me just come here. I'll just change it in the properties. So we can pick a different color of gray, or come here, you know, and create a custom color. So I'll just pick something a little bit darker than what's already in the basic colors and set that to OK. That looks pretty good. So everything there is done. Now what we need to do is just define where our tool locations are going to be. Because this is an external threaded, basically, you know, external thread clamping nut, we want the tool to appear. You're not going to have like another holder typically here or anything like that. So what I'm going to do is just snap the location to this front face here. So when my tool appears, I want the beginning of the tool or the shank of the tool to appear at that plane and then project outward from there. So to do this, when you create a tool location in Esprit, you want the blue pointing up into basically like the tool holder, which this is basically the tool holder here. So this orientation already of the UVW is correct. So I just need to translate it over to the center of this face right here. And how do I do that? Well, I could come here and just pick translate, and then when I move my mouse around, you can see that, you know, depending on what I'm picking, if I go to an extremity, it's going to snap to that where it's highlighted in green. So I've got my green on the face that I want. I'm going to go ahead and click, and you see there that the UVW automatically snaps to that center point of that clamping nut. So now, and you know, just looking at it from the side here, we can see that it's right at that face. So now what I want to do is actually define that. So this is going to be a turning, this is going to be a milling spindle, but it's turning when the mill is engaged. So we want this to spin. It's going to be a tool spindle axis. So we're going to define that using a TSA, or tool spindle axis. So that's how you do it. The tool spindle axis, when I create that, it's going to automatically put a tool and a holder location at the exact same spot. So I just need to create that, and that's it. So now what I want to do is do the same thing on the other one. So I'm going to hit translate again, and I'm going to highlight to that face, and you can see here that as I move my mouse, I want this one. So I'm going to click there, and then I'm just going to come here and say TSA2. And we have basically everything is already done. Maybe what I'll do, I like to make some of these with some blue, just because this is being used on an Okuma. I like to pick this blue here, and now what I'll do is just save this out as my tool holder. So if I go to File, Save As, I'm going to pick Holder File, and this is the name of the CAD model, which I don't want to change. I'm going to come down here to where I loaded it. This is the first one I'm doing this morning. So I'm going to come down here to Velocity. This was for an LB 2000, 3000, LU 3000, and I'm going to add it to my list. So now what we can do is come to Machine Setup, and I'm going to come down here to Okuma, and I'm going to pick, where is it? This one. So we're going to pick the LB3000, and we're going to load that in and kind of zoom in on the turret here. And I'll turn some of the machine components off just so we can see the turret a little bit easier. And then I'll come to Tool Assemblies, just come to Station 1, Add Adaptive Item. I'm going to come down here to the same folder, and let's, okay, that's this one here. So I'm going to just verify that in the window. We can see that this is the one that I just created. When I say open, the holder should appear with the two tool positions basically facing the main. So if I go back here and turn on my machine again, we can see that the tool positions are facing the main. We can see that the face, the mounting face, is flush up against the turret position face. You can see our little blue there. Say OK. And then I can come in here and say, let's add an end mill. Just take the default here, and you see that that appears correctly in the position 1. You know, I didn't model a collet nut. Not really worried about that. That's going to be inside of, you know, this collision checking geometry anyway, so it's not a big deal. But got some nice detail to this holder, and we got a little bit of blue there for the Okuma, and so that's it. Everything seems to be working. You could use this holder now to program operations and simulate and do your linking and collision checking.